Okay, so what we did today was graphing systems of inequalities. We've already done graphing before of systems. We did that on Tuesday. And we've already graphed inequalities. So today we're doing both of them together, meaning we're going to graph two lines that are inequalities. Remember that a system just means two. So the first part here asks us, state which of the following points are solutions to the systems of inequalities graphed below. So if you notice, this first line, they're actually shading below the line. The second line, they're shading above the line. We only want the solutions, the solutions are only where they overlap, here. Any points here are going to be a solution to the system. So when you plot them, 0, 0, 1, negative 1, 4, those are in the shaded area. But if you look, 2, 5 would be out here, and that would not be in the shaded area. So it is not a solution. 0.51 is slightly outside of the line, so also it is not a solution. All right, and then 3, 2 is where they intersect. Now, not always will the answer where they intersect be a solution if it's an inequality, but if they're both solid lines, meaning they're equal to, and they intersect at that point, then yes, it would be a solution. Okay? All right. Now, the next part, if you have your calculator, you can graph it. You'd have to graph it as a relation and use the inequality signs. If not, then you can just do it by hand, which if it's a vertical horizontal line is pretty easy. In order for us to do this, I gave everybody these notes right here. So if you want to pause the video and take them, greater than, that means you'll shade above, and it'll be a dashed line. Greater than or equal to, you still shade above, but it's a solid line. Less than, shade below, dashed line. Less than or equal to, still shade below, but then make it a solid line. So if you want to pause it, copy it, there it is. All right. So this is going to be a horizontal line, crosses the x-axis at 5. Vertical line, crosses the x-axis at 5. It is a greater than sign, so it's dashed. And we shade to the right because the numbers to the right are greater than. Well, I told my class not to shade yet, just to put arrows going to the right of the whole line. Then this second line is a horizontal line. It is less than or equal to, so we're shading below, and equal to means we're going to have a solid line. And we're going to be shading below, so we put arrows going down. I asked my class only to shade where they overlap. Our solutions are anything in this area. Second problem, very similar, horizontal and vertical, where it crosses the y-axis at 0 and the x-axis at 0. So both are at the origin, but the horizontal line is going to be a dashed line because it's less than, and it's going to be shading below because it is less than. So dashed line, horizontal line, pointing arrows going down. Then vertical line, x is greater than 0, so goes through the 0, make a vertical line. Because it's greater than or equal to, the equal to tells us it's a solid line. And all the numbers to the right are greater than 0, so that's why we put arrows going to the right. If you notice, the arrows will overlap here, so anything here is a solution. I even picked a point, 5, negative 2, to try out and see if it makes it true. So these are the two equations we had. I picked that point, 5, negative 2. Negative 2 is the y value, so y, I put negative 2 here, and then negative 2 is less than 0, so that makes it true. Then we tried the x coordinate. 5 is greater than 0 or equal to, and it is also true. So anything in the shaded area is a solution. All right, this one, I asked the class to be careful because this bottom one you have to solve for y. So when we're solving for y, remember we get rid of the x first by canceling out, doing the opposite. If I have a positive 1x, then I'm going to subtract the 1x. What I do to one side, I do to the other. Now that leaves me with a minus y or a negative y, and I never want the y to be negative, so you still have to divide everything by a negative. Be careful when you divide by a negative. Don't forget to flip the inequality sign. It was opening to the left, now it's opening to the right. And it changes our signs to the opposite, so this is a negative 1 now, and this is a positive 1x. Because it's less than, it's a dashed line, and we're shading below. And then we did the horizontal line 2, horizontal line at negative 3. dashed line and we're shading below, so arrows going down. This one, the y-intercept was -1 and +1 was our slope, so we went up 1 over 1, up 1 over 1, and it was dashes, and then we shaded below. So they overlap in this bottom area. That's where our solutions would be. All right, and then this was the last one where we didn't have to solve for y because it was already set equal to y. Our y-intercept for the first one is 3, and our slope is 2, so we go up 2 over 1, up 2 over 1. It is a dashed line because it's less than and no equal to, and then we shade below, so arrows going down. Second line, our y-intercept is 1, and our slope is -1, so we go down 1 over 1, down 1 over 1. It is a dashed line because it's less than and there's no equal to, and then we shade below. I asked you guys only to shade where they overlap, so our solution would be anywhere here. Now in our assignment, we start with regular inequalities. So it's just like if you have one equation, so anything in the shaded area or if it's below or above would be a solution when it's just one. When it's two though, it's only where they overlap.